Everyone can hear me? Online students, is my voice is loud and clear? Online students, can you please come for me? Yes, done. So let's start the session, guys. So in the last class, we are discussing about the NumPy. So I'm once again executing the NumPy. Import NumPy as NP. And the latest version for any library, if you want to see the version of a library, what you have to do is just you have to write the library name, whatever the library name, dot underscore version underscore. So this gives you the version. So what version you are working on. So library name dot underscore version underscore. It is going to work when this particular library is imported. First, you have to import the library. When you import the library, once you import the library, then only this particular function will work. Then only it will work. Otherwise, it will not work. Without importing, if you ask, for example, if I ask some kind of pandas, okay, pandas library, pandas dot underscore version underscore. If I ask like this, it is going to throw the error because first pandas is not defined. First, it is asking what is pandas. So first, what we have to do is first we have to import. Example I'm showing. First, we have to import the pandas is the library name. Then it will work. And accordingly, it is going to show the version. Similarly, for the NumPy also, first you have to import the NumPy. For example, you have imported NumPy means you have to use the entire word of NumPy. Since I have used the import NumPy as NP, instead of writing the complete word of NumPy, I will write only the shortcut called as NP. So np.version. So version means the present version which I am working is 1.21.5 is the version which I am working. Now, what is the use of version? Means few codes. For example, let us take like this. Sir, in your system, the code is working. The code is working in your system, but the same code is not working in my laptop. Code is not working in my laptop. Some people will have this kind of problem. So what is why that one will be the same code as it is, the code will be there, but it will not work in one system. It will work in the another system means it has not been updated to the latest version. If you update to the latest version, automatically it will work, right? So in some versions, they are going to do the modifications, some minute modifications they are going to do. For example, as of now, the present version is NumPy is 1.21.5. In the future, they are going to release 1.21.6. assume. Now, whenever they have risen 1.21.6, at that time, what they are going to do is they are going to add some of few functions. So in the Python community, within the Python community, so Python community is a complete free community. Means tomorrow, if you want to, if you feel some function is useful and it will be useful for universal, for everyone, it will be useful. So immediately what you are going to do is you are going to share the same thing, some code and some examples related to that, everything to the Python community. And the Python community team is going to evaluate that one and they're going to upload that one in the latest version. Like this, multiple people has developed the Python. Okay. So it is not with respect to a single company, and inside that, whatever the persons who are working inside the Python, only those people will create these functions. We don't need to think in that way. So free, it is a free community. So multiple people will participate for that and they're going to upgrade this one. Now, every time we'll get the some latest version. Whenever there is a latest version in NumPy, immediately we'll get a mail that whoever has registered in Anaconda, while installing the Anaconda, if you have registered using your mail ID, assume, then in that case, you'll get the latest updates, everything to the mail. Okay, this was updated and these are the modifications was done. Like that you are going to get, right? If you have installed the free version, you may not get the updated mails. Now, coming to this NumPy. So in the last class, we know that how to import a library. Import NumPy as NP and np.version. So for any library, you can see the version. Now, what is the use of NumPy means? NumPy is nothing but it is a combination of NumPy means it is a list plus for loop. list plus for loop. Every time using an empty list and appending. What is the major purpose of creating NumPy? NumPy major purpose of creating NumPy is to do some kind of mathematical operations. Some kind of mathematical operations. Mathematical, statistical, scientific calculations. All this comes under calculations. Okay. So doing some kind of mathematical or statistical or scientific calculations purpose, they have created the NumPy library. Why? Miss example, let us take like this. There is a list 1, 2, 3, 4 like this. I want to add for every value 10. I want to add for every value 10. Or if I want to add for every element, I want to multiply with 4. Or if I want to do with respect to every number, I want to divide by 2. Like this, if I want to create something, every time I'm going to use the for loop, I'm going to take the for loop and I'm going to take one empty list. And for this empty list, whatever the empty list is there, for this time, I'm going to do the append function. Every time this is the common thing is there, right? Sir, why sir? Who asked you to create that one? Means in the future, we may see as per the requirements. Sometimes we may require, for example, let us take like this example. Y is equal to some mx plus c is the equation. Okay. Now y is equal to ax square plus bx plus c is one more equation. In the first equation, we are having the linear. In the second equation, we are having quadratic. Now, what is this x square miss? X square miss x and square of this one. For example, I'm having x with me 1, 2, 3, 4. I want x square. I want x square. I want to create a new variable called as x square. I want to create a new variable x square. How I want to create that one? X into x. X into x means nothing but multiplying the same value to the same value or doing for each and every value square. I want to do the for each value square. Now, generally in the Python, what we have to do is we have to take the for loop, we have to take empty list, and we have to append. So every time I'm going to take the for each value, if whenever I want to do for each value, the word for each value itself indicates that for loop. Whenever you have to use the for loop and you are using the append function, why to create for loop, why to create append every time? Why we can't create a shortcut for that? And they have created the NumPy. NumPy was basically designed for that purpose, right? And if you want to create, for example, let us take like this. Sir, can you explain with a real life example? Okay, let us take like this. In the body, we are having TB. TB means total bilirubin. That is the value. Total bilirubin is the value. TB means not the disease name. Okay. TB means total bilirubin. For example, if you go for some kind of diagnostic center, and if you ask some kind of liver function test, LFT, they used to call it as LFT. If you go to the diagnostic center, any diagnostic center, and if you ask them, I want to take that LFT test. In the LFT test, if you see the report, in the report will have the TB value. For every patient will have the some TB value. And along with that, IB value. What is meant by IB means indirect bilirubin. So either will have direct bilirubin or indirect bilirubin. Means where the TB is equal to DB plus IB. Okay, that is nothing but total bilirubin is equal to direct plus indirect bilirubin. So for example, I have given you the total bilirubin as 6.4, direct bilirubin as 5. Then what is the indirect bilirubin value? How you have calculated that one? Just you have taken from the TB minus IB. Like this, I'm having 5 records. First patient number 1. 6.4, patient number 2, 5.2, patient number 3, 6.1, 5.9, 4, 4.1, 4.0, something you are having like this. And these values are 3.6, 1.9, 4.8, 4, and 3.6, something you are having like this. Now you are having direct bilirubin of 6 patients and at the same time total bilirubin of 6 patients. Now for these 6 patients, you have to calculate the indirect bilirubin. How you are going to calculate? Just by using the TB minus DB, right? Now, let us take the list of values like this: 6.4, 5.2, 6.1, 5.9, 4.1, and 4.0. And direct bilirubin values, this is total. Direct bilirubin values are 5, 3.6, 1.9, 4.8, 4, and 3.6. Now you want to do for each and every value, you want to subtract. For 6.4, you want to subtract 5. How you are going to do that one? In the core Python, if there is no NumPy. What we are going to do is, we are going to take an empty list and we are going to do for each and every value something. For inside that some operation we are going to do, and for this empty list we are going to append. Every time we are going to append. This operation is nothing but this one minus this one. That is operation. Whatever inside some operation we are going to do. And finally we are going to append. So every time for loop and taking an empty list and append is common. So that is the reason they have created a shortcut called as NumPy arrays, which is used to work for each and every value, right? Now got the point? The use of NumPy array. And in the last class, we have seen with respect to NumPy array what 0 dimensions, 1 dimensions, 2 dimensions. Now, similarly, how to work on the 1 dimension. First, let us start with 1 dimension. Later we'll follow the 2 dimensions, right? Now, many of you are getting confused in terms of shape. How the shape. Now, the shape function gives you the output as a tuple of values. Shape function will give the tuple of values every time. Whatever the NumPy array, if for the NumPy array, if you ask the shape will give you, that is NumPy array dot shape. If you ask any array dot shape will give you the tuple of values. If the tuple of values consist of length of shape is equal to 0 means it is a 1 dimension. Length of shape is equal to 1 means it is, length of shape is 0 means 0 dimension, 1 means 1 dimension. Length of shape is equal to 2 means 2 dimension. Length of shape is equal to 3 means 3 dimension. Like this, whatever the length is the dimension. If the length is equal to n means it is a n dimension. Okay, just it is the length. Number of dimensions is equal to length. Now, how this 0 dimension array will be represented means empty tuple. 0 dimension, whatever the 0 dimension is there, 0 dimension will be represented as empty tuple because the length should be 0. Inside that there will be no val, nothing is there. If you ask the array dot shape, whatever the array dot shape, if the array dot shape is giving us the empty tuple as the answer, then it is a 0 dimension. If the array dot shape gives you the empty tuple, it is a 0 dimension. If it is giving only one value, inside that whatever the value can be anything, but only one value. Let us take 2 comma, something it has given. Means if you ask length, what is the length function? Length means number of values in this tuple. How many values are there in this tuple? 1 value is there. So it is a 1 dimension. So next, if it is showing 2 comma 2, it is a 2 dimension. 2 comma 2 comma 2. 3 dimension. So it is going to represent the total number of dimensions will be represented as length of the values, right? Now, so if I go with the NumPy array, okay, NumPy array. So for example, let us take like this. One of the example is this one only. A is equal to np dot arrange of 10 to 101 with a increment of 10. So 10, 20, 30, 40, 50. I'm going to get as a array of 10 values. In this array, total how many values are there? 10 values are there. 10 values are there. Values are 10. Now, how many dimensions of this particular array means it is a 1 dimension. So it is open with a single square bracket means it is 1 dimension. Now, if you ask the shape, of this one, that is, if you ask the shape of this one, a dot shape, if you ask the shape, it is going to print 10 comma. 10 comma means 10 values are there and it is a one-dimensional array. And if you ask the length of this one means how many, what is the length? It is 1, which is equal to your dimension. So if you ask with respect to a dot ndim, ndim is nothing but number of dimensions. Is that clear? So the shape of one dimension will be represented as number of values, comma. That's it. Sir, how about 2 dimension? That we'll discuss in the later. Forget about 2 dimension, 3 dimension. As of now, there is no 2 dimension, 3 dimension. Just focus only 1 dimension array is there. For 1 dimension array, the shape will be represented as number of values in 1 dimension, number of values, comma. The second value will be empty. Nothing will be displayed. This is the shape of one-dimensional array. Okay. Now, a.arrange function is used to create a one-dimensional array. So functions which are used for creating one-dimensional array is within that one of the function is arrange. Arrange is one of the function which is used to create the one-dimensional array. Similarly, line space is also used to create the one-dimensional array, right? And zeros is used to create the one-dimensional array. Okay, zeros also used to create the one-dimensional array with list of zeros, all the values of zeros. So here for np.zeros, the input should be given as shape. So I'm giving the shape. Shape is one-dimensional array. Shape is 3 comma. What is meant by this one? 3 values with 1 dimension. So since it is np.zeros, so all the 3 values will be filled with zeros. Or simply, you no need to even write this one also. If you don't write this one, automatically it will consider as 1 dimension. np.zeros of 3, if you write just np.zeros of 3 means just it is a 1 dimension with 3 values. Okay. Similarly for ones also same. np of ones of 3s. 3. So you are going to get 3 values with a array of 1, 1, 1. Next, random.randint. So randint means it is going to select the randomly integer. Randint means randomly selecting the integer, which is 1 to 41 comma 5. Means from 1 to 41, 5 values it is going to select randomly. Right? Is that clear? As one of the student in online, he is asking, sir, line space. So now coming to the line space. Now what is meant by line space means? So it is going to take line means this, space means equal distance. Everything should be equally spaced. Like that, how many values should be spaced means 6 values between 0 to 10. Both of them should be included. This one and this one also should be included, and equal spacing should be given between them. That is the meaning. Line space means in a line, I want the list of values which are having the equal space. The space between these two is 2. The space between these two is 2. The space between, the space between, the space between. That is the meaning of line space. Is that clear? Which is a one-dimensional array, right? Total 6 list of values. For example, I want only 5. Okay, now let us take 5. Means line, total of 5 values. 1, 2, 3, 4, 5. Which are equally distributed between 0 to 10. Between 0 to 10, all the lines should be equally distributed. Okay. Now, between, if I fill with 2.5, 5 and 7.5, then everything are equally distributed. So I'm going to get answer as 0, 2.5, 5, 7.5 and 10 as the answer if I execute. Got the point? Just it is going to take the equal distance. Next, how to access the elements or extract the values. So np.arrange of 10 to 51 with an increment of 10 means I'm going to get 10, 20, 30, 40, 50. So 10, 20, 30, 40, 50. Since NumPy was created based on the list. How the list properties are applicable in the same way. In the list also we have discussed in the same way, where it is going to have the positive indexing. Similarly, negative indexing. Okay, positive indexing starts from 0 to n minus 1, that is length minus 1. Negative indexing starts with respect to negative side, that is minus 1 to minus length, till minus length, right? Now, if I am asking a of 1, within this a of 1, what is there? 20. So it is going to give the 20. Whether it is a int 20, no, it is a array of 20. So now if you check this type, what is the type of this one? If you type, it is a NumPy array. The output is a NumPy array. It is not the, because here the list of values, it is not the list of values. This is not the list of values. It is an array of values. Array of values means combinedly, right? Now, so that is the reason you are going to get the output. The output, whatever you are going to get is in terms of this. Okay. Now, a of 1. What is meant by a of 1 means you are going to get answer as 20. Similarly, negative indexing. What is a of minus 1? 50. Same in the list of how we have got. Similarly, multiple values. If you want to get the multiple values, how we have to use slicing operation. In the list, we have done the slicing operation. Here also we are going to do the slicing operation. 1 slicing 5 to 2 means 1 to 5 with an increment of 2. What is increment of 2 means 1, 3, 5. Where 5 should not be included means 1 and 3. What is there in the index position 1? 20. In the index position 3, 40. So 20 and 40. You are going to get an array of 20, 40. Is that clear? Now, this is what we have done in the in the list also we have done the indexing and slicing operation. Now, the question here, slicing. What is the use of slicing means if there is you have to get the extract the multiple values. What is the slicing? What is the use of slicing means extracting multiple values. You are going to get the multiple values based on the pattern, some pattern. Because this is the pattern. Every alternate number you are going to select. Now, what I'm going to do is here, I'm going to access the, for example, let us take a list. Let us take like this. L1 is equal to 40, 80, 10, 20, 6, 4. You are having a list like this. Now in this list, I want the output. I want the output 40, 80, and 6. This is my required output. Then what I have to do? Forget about NumPy. There is no NumPy. Core Python. Now tell me the core Python code for the required output. 40, 80, 6 based on the index numbers. Means I want the index numbers of 1, 2 and with respect to, sorry, index numbers 0, 1, 2, 3, 4. I want index numbers, this one, index of 0, 1 and 4. Now for this, what is the Python code I have to write? General core Python code. You can't apply slicing operation because there is no pattern is available. So slicing is not applicable here. Then what we have to do? Then we have to take the append. So first you, whatever the index numbers you want, the list of index numbers are 0, 1, 4. Now what you are going to do for I in L1, sorry, for in this index numbers, let us take index numbers as index. For I in index, okay. Now what I am going to do, L1 of I. L1 of I means first index number of 0. L1 of 0 is 40 and this 40 will be appended in the L. L dot append. And I'm going to print the L. Right? This is the one which I'm going to write. So first it is going to take 0. L1 of 0 is 40. Next it is going to take 1. L2 of L1 of 1, that is 80. Next it is going to take 4. That is L1 of 4 is 6. Every value will be appended there. Means you are going to take this is empty list. This is operation. And you are going to take append for loop. Now what you are going to write? The index numbers, list of index numbers which you want. Now the same thing, how I can write in the NumPy is same to same as it is how we can use in the NumPy. Now if you are working on the NumPy, first this list you have to convert to an array. A is equal to np dot array of L1. This is the first step. First line of code you have to write. Now within the A, earlier, if you have written only one index number, whether it is a positive index number or negative index number, you have written only one. Now you are going to write the multiple index numbers. What are the index numbers you want? Miss 0, 1, and 4. But whenever you want the multiple index numbers, you have to take the list. When it is a single number, normally, when you are working on the multiple numbers, list of numbers. So 0, 1, and 4, if you write like this, now the output is going to be 48 and 6. If you want, you can see now. Okay. Just I'm writing the code here. L is equal to L1. Whatever the L1 is equal to list of 40, 80, 10, 20, 6, 4. Now, first, what is the first code I'm going to write? A is equal to np dot array of L1. First, it is converted. Now, whatever the A value I'm having, within the A value, I'm going to select a list of 0, 1, and 4. And I'm going to get 40, 80, 6. Is that clear? If you want to access a single value, you have these both, whatever this one, positive indexing and slicing operation, this we have worked on the list. The same concept which we have done on the list. But in the list, what is the drawback? Means if there is a sequential pattern, some pattern is available only, we can apply the slicing operation. If the pattern is not available, means we have to use every time for loop only. Right? We have to use the for loop only. Otherwise, without using the for loop, we can't get the output. So the same for loop here I'm going to use by using this one. So now tell me L is equal to 10, 20, 30, 40, 50, 60, 70. A is equal to np dot L. Now, what is the output of this one? A of 0, 1, 4, 6. That is 0, 1, 2, 3, 4, 5, 6. That is 10, 20, 50, and 70. Sir, can I repeat the things? Yes, you can repeat. What are the list? For example, if you take L is equal to 10, 20, 30, 40, 50, 60, 70. Now, this is your L, assume. This is your L. Now, you are going to take index numbers. What is the index numbers you want? List of 0, 1, 4, and 1. You are going to take one empty list. And for that for loop, you are applying for I in index. And L of I, whatever the L of I, and this you are going to append in the L1 dot append. This is the backend code of that. Print L1. This is the backend code of this particular line. Just it is whatever the numbers you are writing here, it is going to take the list of values. Here, if you repeat also same values, it will also repeat. If you don't repeat, it will also not repeat. Whatever you are writing, it will take this value. This list of values is this values. Got the point? Backend code is clear. So just it is going to take, instead of one value, you are going to select the multiple values. If you want, you can repeat, you can do anything, right? This option is there. Now, what is the answer of this one? A of 0, 4, 7, 5, 4. 0, 1, 2, 3, 4, 5, 6. 0 means 10. 4 means 50. 7. What is there in the 7? 7 is not there. So index error. Maximum value is 6 only. So you have to write 6. Now 10, 50, 70, after that 60, and after that 50. So that is the output. Right? Now, okay, done. So this is the additional option. One way is of using indexing, and one way is of slicing, and one way of list of index numbers. This is the third option, list of index numbers. This option is not available in the list, normal list. In the NumPy, list of index numbers is the option is available. Fourth option is there. Now, let us take like this. One more example. L is equal to 10, 4, 1, 2, 5. This is the list. From this, I want all the even numbers. I want all the even numbers. What is the code I have to write? A normal core Python code. First, you have to take an empty list. Okay. Per I in L. Okay. First, you have to check whether this I is divisible by 2 is equal to 0. This is if. Okay. If condition. Okay. Next, if this is condition satisfied, whatever the I value is there, that you are going to append in the L1 and print the L1. This is the normal core Python code if you are writing using the list. Now the same question, L is equal to 10, 4, 1, 2, 5. Now the same question was asked in the NumPy. Means what it is going to do means L1, it is not going to create anything like this. Directly first it will create an array. np.array of L. Whatever the L is there, and array converted. Now A ready. Now within the A, now write whatever the condition you have given here. That is nothing but one, that is A of this value. Whatever the I is there, nothing but A divisible by 2 is equal to 0. Sir, what is this, sir? A of, again, A of divisible by 2 is equal to 0, 0. Okay, let me explain. If I don't write this one, A divisible by 2 is equal to 0, 0, means what happens? A, what is meant by A? A is array. Array means what? For loop. So it is going to check for each value, it is satisfying the condition or not. First, it will ask 10. 10 divisible by 2 is equal to 0. Whether the condition is true or false? True. So the output is true. Comma 4. 4 is divisible by 2 or not? True. Again true. Because double equal to is a comparison operator. Comparison operator always gives the output as Boolean, either true or false. So it will give the true or false as the output. So true, true. And first one is false. And the next one is true and false. You'll get the output like this. If you ask the question up to here, means the output will be like this. No, sir, I want whichever the output values are true, those values I want to print, means A of, if you write like this. Now, first position, second position, and the third position values are true. What is there in the first position? 10. Second position, 4. In the fourth position, 2. So this is the output you are going to get. That is the meaning of that. Just let us check the same thing. So whatever the question I have written here, the same I am writing. L is equal to 10, 4, 1, 2, 5. This is L. A is equal to np.array of L. Now, for example, now I am going to write like this, up to this one only. A divisible by 2 is equal to 0, means it is going to give me the output as true, true, false, true, false. Because it is considering the comparison operator, and based on the comparison operator, it is either giving true or false. I don't want like that. I want the values which satisfies this condition. So the values which satisfies the condition, those values should be selected. So this one. Now I'm going to get the values. That is the syntax in NumPy. Now, whenever I have written this one, what happens in the backend means this is the code. The backend code is this one. Syntax is this one. The code is this one. Just it is going to take the empty list and it is going to apply the concept same to same. Nothing will difference. This is called as fancy indexing or mask indexing. Fancy indexing or mask indexing. What is meant by fancy indexing or mask indexing in NumPy? They will ask you the question. What is meant by fancy indexing or mask indexing in NumPy? NumPy means you have to say extracting the values, extract the values from an array, extract the values from an array, extract the values from array using a condition, So simply to say, what is the syntax? What is the syntax for this one means syntax. Syntax is nothing but you have to write the array and inside the array, you have to write the condition. Just you have, this is the syntax. Array name, and within the array name, write whatever the condition you want. And based on the condition, whichever the value satisfies the condition, it will print the output. Right? Now, sir, I can write only one condition. I can write 2 or 3 conditions also now. Anything. If condition, if you take the if, you can write only one or you can write multiple also. You can write multiple also, right? Logical operators are available. If you write either and or using anything. If the final output is true, means that value will be printed. If the answer is false, means that value will not be selected. Whichever the value gives the output as true, that value will be printed as the output. If it is not, means it will throw the, if for example, if it is not satisfying the condition, means it will not give the answer. For example, inside this, sir, SRK, you have taken SRK. Now, you have converted L is equal to array. Array also will be converted. Up to this one also no problem. But when you are asking SRK divisible by 2 is equal to 0 is equal to 0, type error. Because SRK you can't, that is string. String you can't divide, right? For string you can't apply the arithmetic operators except plus symbol. That too, it will be accept only when both of them are strings. String concatenation only is possible. So now what happens? It is going to throw the error that to third line. Second line also not a problem. It will convert to array. Array also will be not a problem. But type error because SRK cannot be calculated with respect to %2. Is that clear? But if you ask only up to this point, absolutely not a problem. Yeah. So now if you print the A value, if you open the A value, 10, 4, 1, 2 and SRK. Absolutely not a problem. But for this, you can't apply the mathematical operators. Sir, array, you told earlier NumPy. NumPy means numerical Python. Now, how the SRK you can convert as an array, sir? I told you NumPy means numerical Python. Exactly. Num means numerical. Okay. At the same time, I told you array is developed based on the list. In the list, you can have the any value. Creating a list is not a problem. Applying the for loop, for example, let us take like this. List is equal to A, B, 1 and 2. And now I'm writing as empty list, one empty list. And for I in L and L1 dot append of I and print L1. I'm writing like this. Is there any problem in the code? Is there any problem in this code? Then there is no problem in the array also. If there is no problem in this code, why there will be a problem in array? If, for example, I'm writing like this. For I in L, whatever the I is equal to I plus 10. And that one I'm going to store in the J. And this J value, I'm going to append in the L1. L1 dot append the J. Now, first it is going to take A. For I in L means A. A plus 10. How A plus 10 will be applicable? So normal core Python is not working. Core Python is not working means how NumPy will work? Because NumPy was created based on the core Python. Backend one program is there. The program is this one, the program. Backend program is not working, then how NumPy will work? Got the point? If this is working, NumPy also works. If this is not working, NumPy will not work. Then, sir, what is the difference, sir? If both are same, then what is the, instead of writing 4 to 5 lines of code, you are writing 1 line of code, bringing to the shortcut. I don't want shortcut, sir. I will write lengthy code. Okay, enjoy. Then don't need to learn the NumPy also. Why we are learning NumPy, why we are learning pandas, why we are learning the matplotlib means to reduce the lines of code. That is the advantage of Python. So many big programs also we can write just in 1 line of code. Because officially we can see only 1 line, but in the backend, so many lines will be executed. Okay. From the front end, only 1 line will be visible. Is that clear? So that is. So next you are going to take a of percentage 2 is equal to 0 means whichever the value satisfies the condition, just it is printing the values. Is that clear? And now how to modify the values in an array? For a one-dimensional array, how to modify? Means just whatever the a value is there. Now what is your latest a? A is 10, 4, 1, 2, 4. Because this is the latest a you have converted, right? This is the last stored a. Before to that, whatever the a's are created, that will be erased automatically. So this is the last stored value. So last stored value is 10, 4, 1, 2, 4. For this, you are going to append 110. What is meant by append? Append means it is going to add the element at the last. Adding the value at the last. Now here np.append of 110 comma 120, a list multiple values. If you want to append multiple values, this is the example for appending a single value. So the same thing I have written here, adding a single value and in a array. How to add a single value in array means this is the function. What is the syntax? What is the syntax for adding a single value in a array means the syntax. Syntax for adding a single value in a array means array dot. Okay. So np dot append function, we have to take np dot append function, and for which array you want to add array, comma, which value you want to add. This is the syntax. Okay. np dot append is the function name. And whatever the array you want to add and whatever the value you want to add. Now, whenever you have selected these two values in the function, these are the two compulsory arguments. Whenever you have given these two arguments in the backend of def of append function within the NumPy, def of append function of two arguments. Argument number 1 is a, argument number 2 is v. What it is going to do means for loop it is going to apply and it is going to append the value in the backend. That is the code they have written in the back. NumPy is the module. Within the module, this is one of the function. I told you, right? In the math, how we are having the square root function. In the math, how we are having the factorial function. In the modules, how we SRK, within the SRK module, how we are having add function. Similarly, here also in the NumPy, append is one of the function. Now, similarly, whenever you are writing here, so np.append, this is the syntax for adding a single value. Now, what is the syntax for adding a multiple values? Means np.append of a, comma, list of values. So list of 110, comma 120. Now, what is your a value? Just if you print your a value, what is a value? A value is 10, 4, 1, 2, 4. So this is your a value. For this a value, you are adding the 110 and 120. Sir, I have appended 110 now. After appending, why it is not storing in the original one? So what I'm going to do, this I'm going to write in the A is equal to np dot append of A comma 110. Now, whatever the value is appended, it is going to be added. And finally, it is going to store in the A. If you don't write like this, then by default, it is not going to store the values. Is that clear? Similarly, how to replace a value? How to replace a single value in a one-dimensional array? Now, once again, I'm asking what is A? A is 10, 4, 1, 2, 4. Now, within this, A of 0, what is A of 0? 10. 10 I want to replace with 120. Now, it is getting replaced with 120. Same to same, we have worked in the list. Okay, this one we have worked in the list, and this one also we have worked in the list. But this one is not available in the list. Now, here, you might ask me a question. Sir, you are appending the 110 and 120. Now, why it is not appending as a list? Generally, in the list concept, it has to append in the list, right? But it will not append as a list because here it is applying for loop each value. For each value it is going to take, it is the append function will not have internally list. All of them are single values on. Means it is just going to do the extend function. It will apply the extend concept. Right? Now, next, here replacing the multiple values. I want to replace multiple values. Once again, I'm asking my A value. What is A is 154, 1, 2, and 4. Now, this time what I'm going to do is 1, 4. Index numbers 1, 4. I want to replace with 800. What is there in the index of 1? This one, 4. It will be replaced with 800. Similarly, this one also will be replaced with 800. These two values will be replaced with 800. So this possibility is not there in the list. If you want to do in the list replacement, for example, let us take like this. List is equal to 1, 4, 9, 16, 2. Okay. Now you want to replace 4 with 40, 16 with 20. 4 with 40 you want to replace, and 16 with 60 you want to replace. Assume this is the example, this is the requirement. Now what you are going to do, just you are going to write L of 4. What is that 4? That is index number 1, which is equal to 40. Similarly, L of 0, 1, 2, 3, index 3, you are going to write 60. These are the two lines of code you are writing. The same thing in the NumPy array, you can write as A of list of 1, 3 is equal to 40, 60. If you want to replace two different values, if you want to replace with a common value 40 means single value. If you write right side two values means two different values will be replaced. One will be replaced with 40, 3 will be replaced with 60. Sir, if I write like this, A of 1, 3, 4, but right side I will give 40 and 60 only, then it will throw the error. Left side, if 3 index positions are there, right side 3 value should be there or 1 value should be there. If 1 value is there, means every value will be replaced with the single value only. If 3 values are there, means it will apply the concept of respectively. But you can't have with respect to here left side 3 numbers, right side 2 numbers. These things are not possible. Is that clear? See, A of 1, 5 or 1, 4, I want to replace with list of 100, 800. So it is getting replaced. Okay, if I write left side 900 like this, throw the error because left side you are selecting 2 values, right side 3 values are there. How I can do the replacement? So left side 2 values, shape is 2, right side 3 values, which is shape is 3, right side. Got the point? Either 2, you have to write 2 values. If you want to replace with a single value, means write a single value. Directly you take a single value. Then no problem. Otherwise, take with at least 2 values. Whatever the 2 values you want to replace. Got the point? Similarly, how to delete a single value in an array? How to delete means np.delete. np dot delete a comma 1. A comma 1 means index number. Index number 1 will be deleted. That is 100 will be deleted. 151 to 800. Index number. You have to write the index number. If you want to delete multiple values, you have to take the list of values. What are the list of values you want to delete? That is, I want to delete 1 and 2. Then it is going to delete the index number of 1 and index number of 2. Single value means write the single value, list multiple values means list of values. Okay. Whenever you want to take multiple values, list. Always remember list. Next, copy. So dot copy. What dot copy? Dot copy means it is going to create a Xerox copy. So A is equal to array of 1, 2, 3. A is equal to array of 1, 2, 3. B is equal to array of 1, 2, 3. A dot copy means this one also one more copy. B of 0 is equal to 100. Means this part is replaced with 100. Print A. Print A means 1, 2, 3. Print B means 100, 2, 3. So it is going to print like this. 1, 2, 3 and 100, 2, 3. Just same to same. List. There is no difference. List dot copy means how it is going to do same to same. Right? Next, sort. Sort. So it is going to do the sorting. Right? List dot sort. How the list dot sort is there? Same to same. Same sorting. Right? Is that clear? Sorting. Now, main advantage of NumPy is this one. A is equal to array of 1, 2, 3, 4. For each value, if you want to add 1 means just A plus 1. A plus 1 means for each value, it will add the 1. If you want to create the square for this one, A is this one. A is equal to 1, 2, 3, 4. For each and every value, you want to do the square. That is 1, 4, 9 and 16. Just you are going to take the power 2. Square means power 2. For each value, it is going to do the square. Now, here, if you take the A is equal to np dot array of 1, 2, 3, 4. A is equal to array of 1, 2, 3, 4. B is equal to 5, 6, 7, 8. C is equal to 1, 2, 3, 4. Right? Now, A plus B. What is there in A plus B? A plus B means 1 plus 5. For each and every value, whenever it is a NumPy array, automatically for each and every value, that is 1 plus 5. 6, 2 plus 6, 8. So 6, 8, 10, 12. This is the thing you are going to get. A plus B means 6, 8, 10 and 12. Similarly, A minus B. A minus B means 1 minus 5 minus 4, 2 minus 6 minus 4, 3 minus 7 minus 4, 4 minus 8 minus 4. You are going to get like this. A minus B means minus 4, minus 4, minus 4, minus 4. Next, A into B. A into B. What is A into B? That is 1 into 5, 5. Next, 12, 21, 32. 5, 12, 21 and 32. For each and every value, it is just applying. So, for example, let us take here 5 is there. 5 values are there. Here only 4 values are there. Now, in this case, if you ask A plus B, error. A minus B, error. A into B, error. If both the values are length is not same, it will throw the error. Simply, it will throw the error. If one of them is high and one of them is low, miss, it will throw the error in any of the case. Just if you want, you can try here, comma 5. Just keep the comma 5. Now you are having A is equal to 1, 2, 3, 4, 5. Just ask A plus B. Error. Because one is having the shape of 5 and one is having the shape of 4. 4 comma means a one-dimensional array with 4 values. 5 comma means a one-dimensional array with 5 values. So A minus B, again the same error. A into B, again the same error. Same to same error that shapes are not same. None of them you can apply. Is that clear? If everything are same, then only it will execute that one. Next, A is equal to B. For each and every value, it is checking whether both of them are equal or not. Is equal to means what is the output? Comparison operator output is Boolean. So it is checking 1 is equal to 5. Is equal? No. False. 2 is equal to 6. False. 3, 7. No. False. 4, 8. False. So it is going to give the all the values as false, 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 false. 4 values false. Now A is greater than B. That is 1 is greater than 5, 2 greater than 6, 3 greater than 7, 4 greater than 8. So for each and every value, by default, for each and every value. Is that clear? Sir, I don't want to check for each and every value, sir. For example, now if you ask the same question, A is equal to C. A equal to C. Now you are going to get true, 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 true for each and every value. Sir, I don't want like that. I want to check overall. Overall, this entire array is equal to this entire array. Similarly, this entire array is equal to this entire array. I want to check in that way. Complete array. Then the function name is called as array underscore equal. Now overall array it is going to check. That is overall array of A, that is 1, 2, 3, 4, and overall area of 5, 6, 7, 8. Whether both are same? No. So it is going to give the single false, not for element wise, overall wise. Now A and C, 1, 2, 3, 4, 1, 2, 3, 4. Everything is same. Sir, for example, here 1, 2, 3, 4 and 1, 2, 3, 5 is set. If one of the element is different also, they are not same. They both are different. If both are different, the output is false. If every value is same, then only the output is true. Is that clear? Array equal. Array equal is used to check entire array is equal or not. This one, if you write miss, it is going to give the output as whether both of them are equal or not. Got the point? Next, np.arrange of 0 to 6. 0 to 6 means 0 to 5. 0, 1, 2, 3, 4, 5. np.sign A. What is meant by sign A means for each and every value, it is going to apply the sign. What is sign? Sign of 0 is 0. Sign 1, sign 2, sign 3, sign 4, sign 5. Similarly, np.log. Log A means for each and every value, it is going to apply the log to base 10. By default, to the base 10, it is going to take. That is with respect to infinite. Log 0 is infinite. And this is 0. And like this, you are going to get for each and every value. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Total 6 values. Now, whatever you are observing here, it is a warning. It is called as warning. You don't want to see the warnings. These warnings are not a problem. They are not called as errors. They are just warnings. It is giving a warning that you have got one of the values as infinite. Remember this. It is throwing the warning, right? So if you don't want to see this kind of warnings, import warnings and warnings.simple filter ignore. If you execute this code and now if you execute this one, you will not see the warning. Warning also will be deleted. It will ignore because warnings will be ignored by writing this code. Okay. No, sir. If warnings is there also for me, no problem is no problem. Warnings are not called as errors. Errors are different. Warnings are different. Warnings are not having any impact. Is that clear? So if you want to remove the warnings means import warnings. Warnings is a separate module is available. Within the warnings, there is a function called as simple filter. That is a function where you have to give the ignore. Ignore means it will ignore the warnings. Same. This is also one of the module. Within that module, again this one. Right? Now, np.exponential of A. What is A? 0, 1, 2, 3, 4, 5. Exponential means e to the power of 0. What is e to the power of 0? 1. E power 1, that is 2.71. E square, E cube, e to the power of 4, e to the power of 5. Like this, you are going to get the values. For each and every value, you are going to get. Right? So, Sine, log, exponential. Sir, why you have shown us sine, log, and exponential? Like this, multiple marks are there. Cos is there, cosecant is there, and with respect to log to base e is there. Log to base e means ln. This ln means equal to log to the base e. Log means basically it is equal to log to the base 10. If you want to apply for log to the base 2 or any other number, you have to write the log to 2. Right? Like this, you have to write. We will see in the further. Whenever we discuss about this one, at the time I'll explain. Right? And completely that depends upon the requirement. If you are using your logarithmic means, you are going to use the log functions. Log is not required means you are not going to use the log functions. Is that clear, guys? This is with respect to one-dimensional arrays. So arithmetic operations I have shown you, comparison operations I have shown you, and mathematical operations. So multiple operations we are going to do on the NumPy. In the further classes, we are going to increase the number of things. This is the basic part. Okay. So in the NumPy module itself, we are having almost 800 to 900 functions are available. 800 to 900, exact number I don't know. Approximately I'm saying. Okay, 800 to 900 functions are available. Are we going to learn all the 800 to 900? If you learn also, we can't remember. That depends purely upon the situation. On the situation, we are going to select the particular function. Right? For example, let us take like this. One function. You want to work on the, let us take example, cos theta. You want to work on the cos theta. You are a mathematician and you want to work on a cos theta. Theta, where theta is in the degrees. Theta should be selected in the degrees. Or you want cos 45 degrees. This is your requirement. Cos 45 degrees is your requirement and you want to write in the Python. Now, whether you want to learn, you are a mathematician and you want to work on the cos 45 degrees. Now, you don't know whether this function is available or not. First, you don't know what is the function is available or not in the Python. If it is available, in which library it is available also, you don't know. Because till now you have not worked. I also not work. I also don't know. As of now, in the present situation also, I don't know. In a flow, I have written that example. In my entire life, I have never used the cos 45. So I also don't know whether this function is available. Really, it is available also. Really, it is not available also. I don't know. Now, if this situation comes for me, now what I'm going to do means just I'm going to write cos function in Python. I will write the same thing in the Google. Now, online students, can you hear me? Due to internet disconnectivity, there is a problem. Now it is clear. Online students, done. So just I'm going to check in the Google, and first I will download, I will understand that cost function is available within the math library and math.cost. And I will open the shift tab. Shift tab means help function. Within the help function, now I'll understand whether the input should be given in the radians or whether it has to be given in the degrees. Because this function was created by considering the radians or whether it has created using the degree, how I can remember? If I'm a mathematician and I'm continuously working on the trigonometry, means that is common for me, right? If it is common for me and every day I'm using that one, means common. For the first time in my entire life, I'm using the first time, means how I can remember whether it has this function was created using the degree of using this one, or how I can remember, right? I don't know, right? So simply first I will import the math. So what I will do is simply I will import the math. Import the math. And after importing the math, and I will open the math.cost. And I'll open the shift tab. Okay, shift tab is returns the cosine of x, which is measured in the radians. Which is measure x values radians, not degrees. But I want cos 45 degrees. Cos 45. Otherwise, cos 90. What is cos 90? 0, right? Cos 90 is 0. Sin 0 is 0, means cos 90 is 0. So if I ask here 90, it is going to give me minus 0.44. Why it is giving like that? Because it is cos 90 degree radians it is taking. I don't want radians. I want degrees. How I have to convert the radians to degrees? I'm going to open the calculator. Okay. In the calculator, there is an option called as conversion. Within the conversion, there is a converter is available or degrees to this one, right? Angle. Okay. Angle where I want with respect to 90 degrees means radians. So 90 degrees. 90 degrees equal to how many radians means 1.57. So I'm writing here 1.57. I'll get the answer as 0.000, which is almost 0. Got the point? So first you have to convert to radians and then you have to apply. So whether this cost function was created using radians or whether it has created using the degrees, means no one knows. No one is going to remember. Who is going to remember means mathematicians are going to remember. Data scientist will never remember this one because we never came across the cos theta in our entire life as a data scientist. We don't use that one. We don't work on the trigonometry. We'll work on the linear algebra. We'll not work on the trigonometry. So trigonometric functions are not required for us. If it is not required, why I have to learn that one? Why I have to learn? Right? Simple. Clear, guys? Got the point? What I want to say is you don't need to learn every function, but you have to understand. You have to understand what is meant by module, and within the module, what is function. And once you open the help file, you have to understand what is the meaning of that. You should learn, you should know how to read the help file. So many people, they'll open the help file, but they don't know what is the meaning of help file. They'll not even understand the help file. In the real life, in the industry, we used to see the freshers. They'll, if you ask them, hey, just open the help file and please go through that one, miss. Sir, first question they'll ask, sir, how to open the help file, sir? That is the first question. Once they've opened that one help file, later they'll not understand how to read also. Right? How to read the help file also they'll not understand. Here, how to read the help file means, as I've told you, math.cost and just shift tab. Now this is called as this. Sir, how it is opening, sir? Import math you have not done. Already one time import math and shift enter I have done. So in this entire Jupyter notebook, the math will be there. Right? Now, so help file says that math.cost, it is going to take only one argument. That argument is called as x. Some argument, it is going to select some value. And it is going to return the cosine of x. where it is measured in the radians. X is measured in the radians. For X, they have written the word in measures in the radians. So now it is, if I write here the value, some value that is 45 something or 5. Now what it is going to do is, it is going to take X is equal to 5 and it is going to return the cosine of 5 radians. Cosine of 5 radians. For 5 radians, it is going to give the answer. Right? If you want, you can open the scientific calculator also. Cosine of 5 radians, what is the answer here? Just open the scientific calculator. And here you select instead of degrees radians and 5 trigonometric functions. Apply the cos. Cos 5 gives you the 0.283. If here also answer will be the same. Right? If you open in the calculator cos 5, whatever the answer, here also same. Instead of taking 5 in radians, you have to consider in radians, not in the degree. You know how to use scientific calculator, right? Okay. Not this one. Whether you may not know in the Microsoft, but at least you know how to use in the normal calculator, physical calculator, right? Just use the physical calculator. Right? Is that clear, guys? Now let us move on to the 2-dimensional array. So we have worked on the 1-dimensional array, how to create 1-dimensional arrays, and within that, how to access the elements in the 1-dimensional arrays, and how to modify the values within the 1-dimensional arrays, and operations on the 1-dimensional arrays. So we have worked on the 1-dimensional arrays. First one, create 1-dimensional arrays. We have created 1-dimensional arrays by using the various functions, or by using the list. Convert a list to an np.array. np.array of list. Simple. Or we are having arrange function, line space function, zeros function, randint function, ones function, like this. So multiple functions are used for creating an array. Second, how to access the elements. Accessing the elements. Elements or values within the 1-dimensional array. By using the indexing, by using slicing operation, by using the list of index values, or by using the fancy indexing. Which is nothing but condition. 4 options are there for accessing the elements in the 1-dimensional array. Right? Next, we have seen the how to modify. Modify means in terms of add, remove, replace. How to add, we have seen that to single value. How to add a single value. How to add more than one values. How to remove one value. How to remove more than one value. Replace. How to do with how to replace one value. How to replace more than one values. Everything we have seen, right? How we have to add, how we have to remove, and how we have to replace. With single value, how to add a single value by appending function. How to add a multiple values, again by appending function. This time you have to take a list of values. How to remove a single value, np.delete function. Inside that np.delete and array, whatever the array, if you write single value means it is going to remove the single value. If you write list of values means it is going to remove the list of values. Add function is going to work on the np.append function. And replace. Replace is array of that particular value directly with the whatever the value you want to replace. Right? These are the things which we have covered. Modify. Next, we have seen the operations. The fourth one is operations on a single dimension array. Operations like mathematical operations, comparison operations, and finally, what is the last one? Mathematical operations, comparison operations, and arithmetic operations. Arithmetic operations. So these are the things which we have covered in the 1-dimensional array. Any questions out of all of them? As a nested tuple. Nested means that is 2-dimensional. That we'll see. Nested, word of nested is coming means that is 2-dimensional. Okay, nested list or nested tuple, everything that we'll see in the next 2-dimensional. 1-dimensionals are clear. Anyone has one-dimensional question with one-dimensional array? No, right? Let's move on to the two-dimensional now. In that same two-dimensional array, we are going to do same thing. First, we are going to create, followed by we are going to access, followed by we are going to do the modifications, followed by we are going to do the operations. Generally, one-dimensional will work on the arrays. Whatever the arrays are there, generally will work for one-dimensional arrays. Instead of working on two-dimensional array, than this, they have created in the pandas data frame. Whenever you are working on two-dimensional, it is easy to work in the data frame than array. This is easy. But still also, here also we can work. In the arrays also we can work, but rather selecting two-dimensional array and working in the arrays, it is better to work on the data frame. That is easy. Okay, but I'll show you how to work in with the two-dimensional array. At the same time, I'll show you how to work in the data frame also. So one-dimensional array in NumPy is equal to series in pandas. One-dimensional array in NumPy. In NumPy, it is one-dimensional array. In pandas, it is called as series. Same thing in pandas, it is called as series. In NumPy, two-dimensional array. In pandas, it is called as data frame. Okay. So this is NumPy. This is pandas, which we are going to see in the tomorrow's class. That is pandas library. If you understand this one, this is easy because these both are same only. Na? If you understand this one, this is easy because these both are same. Right? Now, let us move on to the two-dimensional array. Before moving to the two-dimensional array, if you have any questions, you can please type your questions, online students. And if you have any questions, or online students or offline students, please, you can ask what are the questions related to one-dimensional. Related to one-dimensional. Don't ask two-dimensional. Sorry. Data type. Data type means, for example, inside this, all the values, whatever the values are there, every value is a int type, then it is going to give the output as int 32. By default, for example, if you open this one, okay, if you open the shift tab of this one, can you see here the shift tab? Now, what is this argument is called as? Start is the name. But what is the argument? Type of argument, default argument, a keyword argument, a positional argument, a what argument? Huh? Line space function. It is a function. Within this function, what is these two arguments are called as? I'm asking arguments wise. Arguments wise, they are called as either default, positional, keyword. Three options are there. Positional argument. First to miss, these two are positional and compulsory arguments. What about this one? These arguments are called as default arguments. Default means if you don't give miss, by default it will select. So here, from starting point is, I'm going to take the start value as 1. End value as 10. 1 to 10, by default, it is going to take 50 samples. Here, what is the question I have written? 0 to 10, 5. 5 samples means total 5 values I have to get. If you don't write 5 means, by default, what it is going to take means 0 to 10 with 50 values. In between 50 values will be there. These are the equal 50 values. Or if you ask with respect to 1 to 10. So these are the from 1 to 10 total 50 values, which are equal distributed. By default, it is going to take 50 values. Why it is taking 50 values? That is default argument. Whenever you have written, I want only 5 values. Now it is returning only 5 values. Why it is returning 5 values? Because you, as per your requirement, you require only 5 samples. If you don't write 5, by default, it is going to consider the 50. So similarly, here, if you see this one, data type is equal to none. Means by default, whatever the data type is applicable, it is going to apply. No, I want all the 5 values, but that too, all the 5 values. See here, 1, 3.2, 5.5, 7.75, and 10. 1, 3.25, 5.5, 7.75, and 10. So it is going to return the sum of float values. I don't want float. I want everything int type. Then what I'm going to write? D type is equal to int. Means everything will be converted to int. What is int of 1.0? 1. Int of 3.25? 3. 5.5, int of 5.5? 5. 7.75 int is 7. 10 int is 10. Got the point? By default, it is going to take the float values. If you don't write the float, if you write int miss, it will give the output as int only. Right? D type is the default argument. If you don't write miss, by default it will consider. Whichever the compulsory arguments, those are compulsory. Remaining are default. You don't need to focus on the default arguments. Okay. Without, they are called as methods. Without, they are not called as with respect to functions. Okay. Endim, whatever the endim and the shape, these both, whatever you are having, these both are not called as functions. They are not called as functions. Yes, methods in terms of if you are opening in the data structures, they are considered like that. Here, for example, if you write here endim, and if you use this one, so first I'll write this one, and if I write like this, int object is not callable. Int object means endim is a int data type. For int data type, this function is not applicable because function is applicable for the output which is having a data structure. So it is going to throw the error. So, and similarly shape. Now, if you ask the shape, instead of shape of this one, if you ask like this, again, it is going to throw that tuple object is not callable because this object was not a function. They are not the functions. To call that function, callable means they are not created as a functions. Functions only you can call. Okay. They have not created as a function. Clear, guys? One-dimensional arrays. So in the tomorrow's class, we'll discuss about the two-dimensional arrays. What is meant by two-dimensional arrays and with respect to how to work on the two-dimensional arrays. That we'll see in the tomorrow's class along with the pandas. Okay, please practice this one. And coming to the statistical operations, that is np.mean, np.median, standard deviation. These things I'll explain when I'm discussing the statistics. When I work on the statistics, automatically I will apply the statistical operations. Statistics in Python will be done using this. Is that clear? So tomorrow we'll discuss the two-dimensional array and already I have uploaded the notes. Please go through the notes. And if you have any questions, you can please ask. Two-dimensional array we'll discuss tomorrow. How to create and how to work. Similarly, three-dimensional array that we'll discuss during the images. When we are working on the images, videos, at the time I'll explain the three-dimensional array. That is the application. Okay. Done. Yes, guys. Still, if you are having any questions, you can ask. Otherwise, you can leave. That is the end of the session for today. Yeah, already uploaded.